What's up, everybody? I'm going to walk you through how to derive the area between the two curves formula that we learned in class. I looked through Dr. Gubkin's lecture notes, and once I sat down and looked at it, it all clicked. So I'm going to try to walk you guys through it and hopefully strengthen your knowledge of it in preparation for your quiz tomorrow. So first things first, we're going to establish the function we're trying to find. So the function we're trying to find is a of t, and a of t gives us the area between the curves from a to t. So on this graph, here's a. T is just going to be a random point that I mark on the x-axis. So I just put it in the middle right there. And once we find out this formula, we'll be able to make t anything. So we can make it b and find the answer to this problem. But for right now, I'm going to keep it at t. And it should make things a little bit simpler. And just to reiterate, this function down here gives us the output of this function is the area between the curves from a to t. So it'll be all of that. And Dr. Gubkin finds the function we're looking for using a derivative. So he'll find the derivative of something. So in this case, it'll be a prime of t. And then you take the integral of that. And that gives you a of t. And there's a different way to find this using the Riemann sum method. But this way, it's a lot more interesting. I've never learned anything like it, so it's really cool to me. So I hope it'll be as cool to you guys once I'm done with this video. So to start, since we're going to be finding the derivative of the function, we need to find a formula that we know that has the derivative involved in it. And I already have it written down right here. It's our change in when we change our input and we get that output, it's that formula. So your output when the input is changed is all of that. So let me talk through it real quick. A of t plus delta t, which is, and I'm doing this in terms of the area function, obviously, which is, so this is your y value for your new input value, is approximately your original output value plus your derivative at your original input times your change in input. So I have everything labeled down there. So if you need to pause and kind of absorb it all in, feel free to do so. So once we have that, we have a formula that involves our derivative that we're looking for. So now, based on this formula and what we have in the picture, we need to find something that we can throw into this formula and get a of t by itself. So if you look at your picture, we know that a of t gives us the area between these two curves. So if we move that input a little bit we move it to t plus delta t, we have this change in output, right? And based on this picture, we can calculate the change in output. So the change in output is going to be approximately, and I'm going to draw a rectangle, that right there, a bad rectangle, but you know. So that's going to be approximately the change in output. This isn't your new output, it's your change in output from t to t plus delta t. So it's a rectangle, it's an area. And we know how to find the area of a rectangle, length times width. And based on the graph and what we have labeled, we can find length times width in terms of our functions and our x-coordinates. So your length is going to be your top y value minus your bottom y value. So in this case, L is equal to f of t minus g of t. So that gives you the length. And then the width is delta t, right? Because we're moving over from t to t plus delta t, so that in between is delta t. So to find the area of this rectangle, you just multiply the two. F of t minus g of t is, well, f of t minus g of t times delta t is approximately your change in output. So now if we look back at this formula right here, we could rearrange it in a way, well, we have to try to find a way to rearrange it so we have change in output that we can substitute this into. So all your change in output is your final output minus your original output. So if this is your final output and this is your original input, your original output, then you can subtract them. So subtract your original output from each side. And we're still using approximate, not equal. So now we're one step closer to having the derivative by itself, and that's what we need, the derivative by itself. So now we have the change in output. And the change in output, well, let me just note real quick that this, as you can see right here, is equal to the change in output. But if we were to substitute what we have up here with that change in output, then we get rid of our a prime of t, and we need to solve for that. So you don't want to do that. So you want to rearrange the equation in a different way to get change of output. So that's why I didn't just replace it right here. I rearranged it to get a new change in output, so we still have that a prime of t we're looking for. So now that we have our change in output, I can substitute it with our change of output from our picture. So that's going to be f of t minus g of t times delta t is approximately a prime of t times delta t, right? And once we get here, we get lucky, and you can cancel, you can divide by delta t on both sides. So that leaves us with a prime of t, and it also turns that back into an equal sign because you're getting rid of that delta t. So now we're just left with f, I'm going to write it the other way. A prime of t is equal to f of t minus g of t. And now if we want to find the area function, we just integrate both sides, right? So then the integral of a derivative is just the original function. So that's a of t. And then it's going to be equal to f of t minus g of t. Right? So that's how you find it. This integral gives us the area. That's what we were looking for. So, quick recap. We wanted a of t. The way we're going to find a of t is by taking the integral of a prime of t. So, to get a prime of t, we have to use a formula that has a prime of t in it and get it by itself. And we need to establish what a prime of t is. And to do that, we can look at our graph and see what we can pull from our graph. Just so happens that the way we labeled it gave us a way to calculate approximately the change in output. So once you calculate that change in output, you're able to rearrange this formula we have. Nope, not that. This formula we have down here. Rearrange it so that change in output is on one side. Once we have the change in output on one side, substitute it with our information we got from our graph, and works out so you have a prime of t on one side. You integrate that, well, you integrate both sides, and you're left with your formula that you're looking for. So I hope it helps a little bit. And if you guys have any questions, just shoot me a message on Remind. Good luck on the quiz tomorrow, team.